Hello there everyone, welcome back to the channel. My name is Mo. Today we are going to embark on a rather exciting journey to the world of .NET and explore how it operates under the hood. Whether you're tinkering with a console application or weaving an intricate web with ASP.NET, the path your C# code takes from pen to execution is as fascinating as a good cup of tea. So let's crack on. Today we are going to take a deeper look into the world of .NET. What is BCL, CLR, CTS, CLS, and what is runtime architecture? So without further ado, let's get started and talk about all these topics. First thing first, suppose that you're developing an application and it could be Windows Form, ASP.NET Form, whatever, and you're using C# or F# or VB to develop your application. When you're compiling your application, the code will be converted into IL, intermediate language. And in C# Roslyn compiler steps into converting your code into the IL code. And now you might ask why you're converting the code to the IL code and why we are not directly converting the C# code to the machine code. Actually, the magic lies in the flexibility of .NET. .NET has been designed to be platform agnostic. .NET can be run on various environments like Windows, Mac, Linux, Android, and whatever. So this means that each environment has its own CLR, Common Language Runtime, and each CLR optimized for that specific platform. That means your IL code can be executed across different systems, providing a versatile and powerful runtime architecture. When we are talking about the compile time, actually we are talking about this part, converting your code to the IL code. And when we are talking about the runtime, we are talking about the running the IL code in your environment, which could be Windows, Mac, or Linux. At runtime, CLR takes over. It's responsible for executing IL code. Within the CLR, there is a crucial component known as just-in-time JIT compiler, which compiles the IL code into native machine code just before execution, ensuring efficiency and speed. So in each environment, JIT compiler is designed to convert the IL code to the machine code. But that's not all. In your application, you're using dictionary, list, and these kind of essential libraries. Alongside the CLR, there is base class library, which houses essential libraries like list and dictionary. The BCL provides the fundamental components that developers use every day, ensuring consistency and reliability across different platforms. So all those essential components reside on the BCL, and combination of all these components is called .NET. Now let's take a closer look to the CLR. As we talked previously, in the CLR we have BCL, Base Class Library, which hosts essential components and libraries like dictionary, list, threading, file I/O. All these essential components which developers use frequently are hosted in the BCL. We have JIT, just-in-time compiler, which is responsible for converting IL code to the machine code. But that's not all. CLR has also includes Common Language Specification and Common Type Specification, CTS and CLS, which ensure interoperability and consistency across different programming languages. CTS defines how data types are declared and used. For example, C# use int, while VB.NET use integer. But under the hood, both represents as int32. The CTS also determines the storage strategy, deciding whether a value type is stored in the stack or a reference type in the heap. CLS, on the other hand, sets the rules for how different languages can interoperate. For instance, in VB.NET, you don't need to end statements with a semicolon, whereas in C#, it's mandatory. These rules ensure that the code written in one language can interact seamlessly with code written in another. To summarize, .NET's architecture is a harmonious blend of the CLR, CLS, CTS, and BCL, all working together to provide a robust and versatile runtime environment. If you enjoyed this video or found it helpful, do give it a thumbs up and subscribe to the channel for more content like this. Thanks for watching, and until next time, keep calm and code on.